Okay, guys, so let's go ahead and start reading. Is it recording now? Okay. We're going to go over the handout, Gaussian elimination and Gauss-Jordan. Also, I want you to grab some notebook paper because we're going to be taking some notes as we move on. So, Natalie, read the first sentence, please. And whatever you guys see highlighted, please highlight on your paper, okay? Go ahead.
An augmented matrix consists of coefficient consistent terms of a system of linear equations.
All right. So not consistent, but constant terms. So coefficients and constant terms of a system of linear equations. Next statement, Devin. All right. And when we say large systems, I mean, we're going to do a 2 by 2 by hand. 2 by 2 means 2 equations, 2 unknowns. I'm going to show you a 3 by 3. Not fully by hand, but I will tell you what type of operations. We'll discuss that in a minute. But when we say large systems, I'm talking about like 100 by 100, 1,000 by 1,000. Of course, you will not do those by hand, but you could do them depending on the type of computer you have. A computer could solve systems like that, like pretty big systems. All right, so we have here an example of a system of equations, and I actually worked this example with my previous class, and it was a bad idea because it was not a good system. It had a lot of fractions, so I think I scared most of them. So what I'm going to do is find another example from the pre-calculus book that we can work out by hand, and you can see what I'm talking about. After we do that by hand, and we go over the rest of the handout, I'm going to teach you guys how to solve them with the calculator. And that's when all of you are going to go like, oh my god, this is so cool. Doing it by hand is not easy. I want to warn you. Okay, it's a little overwhelming. But the good news is that when you get to pre-calculus, you will already know how to do it. And last year, we didn't used to teach this by hand in Algebra 2. But now we have to. So you guys are lucky, I guess. Pre-cal students, they only learn them with the calculator. So this year, they're going to be pretty overwhelmed when we cover that chapter, which will be pretty soon. Right, Raquel? I don't want to scare you, but yes. All right, so you have your system here, and then you create the augmented matrix. That's the name of it. You notice on the left side we have coefficients, and then on the right side we have the constant terms. So the constant terms are 4 and 10. They're right here. Coefficients are here on the left. Now, let's keep reading. So, Jasmine, read the next statement, please.
Elementary row operations are operations used to change the form of a matrix.
Okay. And Laisha, read the first one.
Interchange two equations, rows.
Okay, so we're going to refer to the equations as rows. So equation 1 will be R1, or row 1. Equation 2 will be R2, or row 2. What we see here is the example of the notation that we're going to be using. So here for interchange two equations, we put R1 interchange for R2. That's an uppercase R. Okay, next statement, Isaac?
Multiply an equation by a non-zero constant.
So in this case, the non-zero constant is 3. So here I'm saying R1 times 3. The next one, Lauren?
Adding multiple of an equation to another equation.
Okay. So here's the example, and here what I'm doing is adding R1 times 3, that's a multiple of R1, plus another equation, R2. Are you raising your hand? Yes.
What if one equation has, like, after the x, it has, like, plus 1 or whatever?
Plus 1. Oh, okay. That's a great question. So what if that equation number 1 was written like this? 7x plus 3y minus 4. right? Something like that? Okay, so what we will have to do is change it so that the coefficients are on the left of the equal sign. And I'm sorry, like in this case, the coefficients with the variables are on the left and the constant term is on the right. So I will have to transform this one by adding 4 to both sides, or by just taking this one across. It is subtracting, so if you take it across, it will be adding, so that will turn into positive 4. So yes, that's a great question. So you always got to make sure that your system is in this form before you write your augmented matrix. Also, we have to make sure that they are in order. So in this case, x's come first, and then the y's come second. So x and y. All right, so now get your notebook paper ready, guys, please. And I want you to write the following. So while you guys copy that, I'm going to go and find the system that I want to use, because I don't want to use that one. It got a little ugly, as you can see here. We had a lot of fractions, which I know you all love. But I just want to, I don't want to overwhelm you the first time you see it. That's why.
So just copy the words or copy?
Yeah, just copy. You can copy the whole thing. And then just stop here. I'm going to look in the book for like a nicer system that we could do for your first one, so you don't hate Gauss Jordan.
Write the numbers.
Yeah, you can write the numbers, but that's fine. Okay, as you keep writing, I'm gonna read what I wrote down there, and then I'm gonna highlight what I think is like the most important things here. So we have a system, the same system from the handout, and so we create the augmented matrix. Coefficients for the x go here, coefficients for the y go here. Now at the end, our goal is to have the identity matrix on the left, and to do that we're going to be able to accomplish that, we're going to use the elementary row operations. Then on the right side we're going to have some numbers. Those numbers are actually going to be representing 1x is equal to a value, and here we will have 1y is equal to another value. And I'm going to tell you what those numbers were. 98 over 63, and y was negative 62 over 27. So that's why I don't want to do that system with you guys. I don't want to scare you. And those numbers will be here. Now, I found another system that would give us solutions. It will have solutions, integers as solutions. So we're going to do that instead of that one. But I still need you guys to write this all of this down. So we will use elementary row operations, what we were reading before, like adding a row to another, or multiplying a constant by a row, and then adding it to another. We must work by column from left to right. So what I mean by that is that we're going to work the first column first, and then we move to the right side. Also, every time that we start a column, we will make a 1 first. When I say a 1, I mean like the ones here, that one. And then we will make the 0. When we go to second column, we'll make this 1 first, and then we will make the 0. All right, that's just the order for them to work. Luis, can you see if it's still recording? Not.
Yeah.
Yep, okay. All right, do you guys copy the third statements here? The three statements? Okay. Someone who's still writing? Raise your hand if you need more time. Okay. Yes.
Did you use the boxes to cover the windows? Or?
Oh, you know what? We could do that. Yes, that's a great idea. Yeah. I'm actually using them for the decorating. You're a genius.
This one doesn't fit.
Okay, I think that makes it a little better. No? Just a little? Okay. All right, so our system is going to be the following. 3x plus 2y is equal to 4. That's the first equation. The second equation will be 2x plus y is equal to 1. So we make sure they are in order. X is first and then y. So to create the augmented matrix, we will have the following. 3, 2, 4, 2, 1, and 1. So remember, this is a column representing x, this is a column representing y. Okay, so our first rule was that first we need to work on the first column, right? So we will make number 3 a 1. That's what we need to do first. So to do that, we're going to use the multiplicative inverse. So if we have a 3 and we want to turn it into a 1, what do we need to multiply 3 by? Not 0.3. Well, how about as a fraction? 1/3. So that's what we're going to do. So using the row notation, we're going to say R1 times 1/3. So we take, what is 3 times 1/3? Is 1, right? That's the purpose of using 1/3. Now, what is 2 times 1/3? In this case, it will be 2/3. Now, what is 4 times 1/3? If you don't know, you get some scratch paper and you multiply it. So 4 times 1/3. You multiply straight across. 4 times 1, 4. 1 times 3, 3. So it's 4/3. All right, now we're done with the first row, so let's just copy the second row from the previous, actually from the augmented matrix.
And we always have to be in X, Y order.
Yes, so if your variables were like A, B, C, then they will have to be A, B, C. That's very important that you keep the columns like that. And with your homework, I'm going to show you what you can do to keep that order. All right, next step, we're going to make that number 2 turn into a 0. So what we're going to do is we're going to use the additive inverse of 2. So what do you need to add to 2 to make it a 0? -2. So then, oh, one very important thing is that now R1 is the leading row.
What does it mean?
So what that means is that what we're going to do is multiply R1 by a constant to turn that 2 into a 0. And that constant that we're going to use is this one, the additive inverse of 2. So R1 times 2. And the reason it is the leading row is because we already have that 1 here. Now remember, our goal is to get to the identity, right? Okay, so you do that and then you're going to add R2. Now the first row is not going to change at all, so I'm just going to copy it. 1, 2/3, and 4/3. And don't worry, after we finish this problem, we'll take a break, because you will need one. All right, now we're going to multiply what is -2 times the first row. So I'm going to write it down here, 1, 2/3, and 4/3. So what is that? What is -2 times 1, Catherine? -2. What is -2 times 2/3, Matthew? -4 thirds. Okay. And then what is -2 times 4/3? If you don't know, you grab some scratch paper and you write it down, okay? Okay, so -8/3. I know you guys don't like fractions, but they're just inevitable. And especially when you get to pre-cal 2, you are going to wish you learned fractions. When you were in, I know you learned them in elementary, but maybe in middle school you stopped using them, right? Because maybe you were encouraged to use your calculator a little too much. All right, so -8/3. Now, what does it say here? We multiply R1 times negative 2, and then what do we do after that? I'm sorry, yeah, and then you add R2. So now we're going to add R2. So, Amaya, read R2 for me, please. From here.
2, 1, and
Okay, very good. So what is negative 2 plus 2? 0, right? That was the whole purpose of it. Now, what is negative 4/3 plus 1? So let's see. We have negative 4/3.
Would it be 1 and negative 1/3?
Well, plus 1. What is the denominator of 1? 1. So what will be the common denominator here? 3. So what do we need to, Laisha, what do we need to multiply 1 to make it a 3? 3. Whatever we do to the bottom, we must do to the top. So now we have negative 4/3 plus 3/3. Right? And what is negative 4 plus 3? Negative 1. So negative 1/3. So that's what goes here. Okay, now we need to do the same here with negative 8/3 plus 1. So let's use some scratch paper. Negative 8/3 plus 1. Now you already know the common denominator is what? 3. So we need to multiply bottom and top by 3. Then we have negative 8/3 plus 3/3. So what is negative 8 plus 3? Negative 5. So we have negative 5/3. And that goes here. So now that one is going to be my new R2. That's what goes here. 0, negative 1/3, and negative 5/3. Okay, so we are done with the first column. But what are we supposed to get on the left side of the augmented matrix? What is our goal? Identity, right? So now we move to the second column. But before we make this 2/3 into a 0, what do we need to do with this? Turn it into a 1. So to do that, that would be step number 3. And we need to make negative 1/3 a 1. So to do that, we're going to use the multiplicative inverse. So if we have negative 1/3, what do we need to multiply that by to get a 1? Negative 3, yes. So negative 3 because negative 3 has a denominator of 1, right? So in other words, it's the reciprocal, like you flip the numbers. Now, why do you tell me negative, Marco?
Because negatives cancel out.
Okay, because they cancel out, or because, in other words, negative times negative is positive, right? And we wanted to make a positive 1, not a negative 1. All right, so then we're going to say R1, I'm sorry, not R1, R2. In fact, let's copy R1 because we're not changing anything to it yet. So R2, we're going to multiply it by this number right here, negative 3. And so that will be, what is 0 times negative 3? 0. What is negative 1/3 times negative 3? 1, right? We have it here. And what is negative 5/3 times negative 3? So if we don't know, we need to get some scratch paper. So we have negative 5/3 times 3. I'm sorry, negative 3. So when you multiply fractions straight across, what is negative 5 times negative 3? Negative 15. And what is 3 times 1? Positive 3. So what is negative 15 over 3? Negative? 5.
The negatives cancel
Oh, I'm sorry, that was positive, sorry. So that would be positive 5. Positive 5. Okay. Now you guys want me to show you the shortcut for this? 3 and 3, they cancel out because they make a 1. And then negative times negative is positive, so positive 5. All right, so that goes here, positive 5. Now we're almost there, we're almost done. Now our fourth step, we already made that 1. What is left for us to do? Turn this 2/3 into a what? Okay, so make 2/3 turn into a 0. So to do that, we're going to use the additive inverse. So, go ahead.
When do you determine if it's a multiplicative inverse or additive inverse?
So every time you want to make a 1, you will use multiplicative inverse. And then you're asking very good questions, Martha. It's like we rehearsed this. And then every time you want to make a 0, you will use the additive inverse. Always, always. Bless you. And I can tell you that because 1 is actually the multiplicative identity. And 0 is the additive identity. Okay? All right, so what do we need to add to 2/3 to make a 0? Negative 2/3, the opposite of 2/3. So negative 2/3. So now one thing to consider is that R2 is now the leading row.
Why?
Because that's the one that has the 1. Remember how we moved from first column to second column? So once you move to the second column, the row that contains the 1 of the identity form is the leading row. Now, we're not going to do anything to R2, so let's just copy it. So 0, 1, and 5. But now we need to do something to R1. But we're going to use R2 as our leading row. So what I mean by that is that we're going to say R2 times something plus R1. And that something is actually going to come from here, from the additive inverse. So negative 2 over 3. Okay, so let's start. So negative 2/3 times R2, that is 0, 1, and 5. So let's see what that is. What is negative 2/3 times 0? 0. Negative 2/3 times 1? Negative 2/3. And then negative 2/3 times 5? Remember, you multiply the numerator, so what is negative 2 times 5? Negative 10. So negative 10 over 3. Now we need to add, it says right here, right? Add R1. So if we add R1, Luis, could you please read R1 for me from the previous matrix?
Wouldn't it be 143?
Right here.
1 2/3 and 4/3.
Very good. So what is 0 plus 1? 1. What is negative 2/3 plus 2/3? 0, right? That was the whole purpose of using positive 2/3. Or negative 2/3. And now what is negative 10 thirds plus 4 thirds. So let's see, if we're not sure about this, we can write it down. Negative 10 thirds plus 4 thirds. So you combine the numerators, so negative 10 plus 4 is negative 6. So negative 6 thirds. Could we reduce that into an integer? Or we divide? Yes. What is that? Negative 2. So now those numbers are the ones that go here. 1, 0, and negative 2. What that means is that 1x is equal to negative 2, and 1y is equal to 5. All right, could you stop the video, please?